Hi guys, welcome to Excel. My name's Josh and today we're going to be learning about functions. So what is a function? Remember, a function is just a graph on a Cartesian plane that is represented by an equation. So let's look at the three functions that we're going to be doing today. The first one is the parabola. Now remember, the parabola is often described as either the smiley or frowny face graph, and it can be represented by two different equations. Now the first equation is y is equal to ax squared plus bx plus c. The second equation is y is equal to a x minus p squared plus q. The second graph that we're going to be looking today is the hyperbola, and this is the one that is normally found in two of the four quadrants on a Cartesian plane. And it is represented by the equation y is equal to a over x minus p plus q. And now the final graph is the exponential one. And this one is the one that grows exponentially into positive infinity or into negative infinity. And this graph can be represented by the equation y is equal to a times b to the power of x minus p plus q. So the first graph that we're going to look at is the parabola. And the first equation that we're going to look at is ax squared plus bx plus c. But what do these values mean? So let's start off with our a value. Now our a value tells us both the shape and the size or width of our graph. And the way the a value does that is if a is greater than 0 or positive, then it's going to be a smiley faced graph. Now if our a is less than 0, it's going to be a frowny faced graph. Now when determining our size or width of the graph, we have a Cartesian plane like this. Now if we have an a that is quite high, like 10, we're going to have a very narrow parabola. However, if we have an a value that is closer to 0, such as 1, we're going to have a much wider parabola. Now if we have a negative graph, it's going to work almost exactly the same way. If we have quite a high negative value, such as -10, we're going to have a very narrow parabola. If we have an a value that's closer to 0 though, like -1, we're going to have a much wider parabola. Now the next thing that we're going to look at is our b value. And what does our b value tell us? Well, our b value is simply going to be our horizontal shift. And this is just telling us how our parabola is going to move along the x-axis. Now the next value that we're going to look at is our c value. Now our c is our y-intercept. And what our y-intercept is where on the y-axis does our parabola cut it. So we can see over here, this is going to be our c value. Now the next thing that we're going to look at is our turning point. Now what is a turning point? Well, our turning point is where our graph goes from decreasing to increasing. Or if we had a negative graph, from increasing to decreasing. Right, and how we're going to calculate our turning point is we're going to use this formula. And the x value of our turning point is going to be equal to minus b over 2a. Now once we've got that value, how we determine the y value of our turning point is simply by just subbing this back into our original equation. Now the final thing that we're going to be looking at is our domain and range. Now the domain for a parabola is quite simple, because our parabola always comes from negative infinity and goes all the way to positive infinity. And that can just be written as x is an element of negative infinity to positive infinity. Now our range is a little bit different. Our range depends on whether we have a positive a or our a is negative. So now when we've got a positive a, we can see that our parabola comes all the way from positive infinity up until our turning point. And we can write that as y is an element of positive infinity to our turning point. And we're going to use a square bracket because we can include our turning point. Remember, we can never include infinity because infinity isn't an actual number. So we have to use a circle bracket. Now when we have a negative a, you can see here that you're going to have a parabola that starts off at the turning point somewhere here. And we're going to write that as y is an element of your turning point, because your graph is going to start at the turning point, and this graph is then going to go all the way down to negative infinity. So we're just going to write here negative infinity. So now we're on to equation 2. And equation 2 is f of x is equal to a x minus p squared plus q. So the only real difference we see in this equation is now we have a p and a q value. And what do these p and q values mean? Well, our p is actually going to be the x coordinate of our turning point. So if we look at our graph here, here's our turning point. This is going to be p. And our q is going to be the y coordinate of our turning point. So if we look at our turning point, this is going to be q. So this is important when they give us a turning point and one other point on the parabola. And we can then use this formula to find the equation of our parabola. So now you may be wondering, how do I go from equation 1 to equation 2 and equation 2 back to equation 1? Well, I'm going to explain that to you using a simple example. So let's start off with the formula y is equal to x plus 2 squared minus 1. Now how we're going to go back to equation 1 is we're just going to FOIL out this bracket. So we're going to say y is equal to x plus 2 minus 1. And we're going to end up with y is equal to x squared plus 4x plus 4 minus 1. And then our final equation is going to be x squared plus 4x plus 3. And then we've got an a of 1, a b of 4, and a c of plus 3. So now we're going to go back to equation 2. So how we're going to do that is by doing something called completing the square, which you may have heard of in your algebra classes. So the first thing that we're going to do is identify our b value. And our b value here is 4. So what we're going to do is we're going to take our b value of 4, times it by a half, and then square it. And we're actually going to end up with 4 again. So now the next step is to get x squared plus 4x by itself. And how we're going to do that is by bringing the 3 to the other side. And we're going to get negative 3. Now what we're going to do now is we're going to add this 4 to both sides. And the reason that we do that is we can't add 4 to one side of the equation without adding 4 to the other side of the equation. So we're going to end up with x squared plus 4x plus 4 is equal to negative 3 plus 4. Now the next step is to just factorize the equation that we have on the left side. So now we're going to have x plus 2 squared is equal to positive 1. And then we're going to bring the positive 1 all the way back. So now we have x plus 2 squared minus 1. And you can see that this is the equation that we had in the beginning. So now we have our p and our q values again. So now we're on to our second function. And this function is the hyperbola, and this is represented by the equation y is equal to a over x minus p plus q. So the first thing that we're going to talk about is the p and the q values. Now the difference between a hyperbola and a parabola is our p and our q values, because our p and our q values represent asymptotes. Now what are asymptotes? Asymptotes are lines that your graph gets very, very close to, but never actually touches. So let's start off with p. Our p is our vertical asymptote, right? And it's actually going to be a vertical line on our Cartesian plane. Now our q is going to be our horizontal asymptote and is going to be a horizontal line on our Cartesian plane. Onto our a value. Now our a value tells us which quadrants our hyperbola is actually going to be in. So if we have a positive a, or an a greater than 0, we're going to have a hyperbola in our first and third quadrants. If we have an a which is less than 0 or negative, we're going to have a hyperbola in our second and fourth quadrants. So now we're going to draw this hyperbola, and we're going to draw it in our first and our third quadrants. But you can see how this hyperbola has been moved up because of the asymptotes. So it's always important to draw your asymptotes first. So now I want to point out something. Look at where your P and your Q asymptotes meet. Now these is actually where you're going to get your axis of symmetry. Now what an axis of symmetry is the lines along which your hyperbola are going to be symmetrical. And they're always going to be drawn through the points where your P and Q asymptotes meet. Now these two lines have two separate equations. Now this line is going to have the equation of y is equal to negative x plus p plus q. And the other line is going to have the equation y is equal to x minus p plus q. And the way that we'll solve for these equations is just by using your linear function methods. So now we're going to look at domain and range. Now our domain for a hyperbola is going to be x is an element of negative infinity to positive infinity. However, we have an asymptote, and this asymptote is a restriction. So we have to state that x cannot equal p. For our range, we're going to do the exact same thing. Our range comes from positive infinity all the way down to negative infinity. So we're just going to state that y is an element of positive infinity to negative infinity. But again, we have an asymptote, and this asymptote is also a restriction. So y cannot equal q. So now we're on to our final function, which is the exponential function. Now the exponential function is represented by the equation y is equal to a times by b to the power of x minus p plus q. So let's look at our a and our b, because these values work in tandem with each other, and they give us the shape of our graph. Now when we have an a that is greater than 0, we have a exponential function which is on top of our x-axis or asymptote if we have one. Let's look at our b value. If we have a b value that is greater than 1, we're going to have an increasing exponential function. However, if we have a b between 0 and 1, we're going to have a decreasing exponential function. Now let's look at our a when it's less than 0. If a is negative, we're going to have a exponential function underneath our x-axis or asymptote. And if our b is greater than 1, we're going to have a exponential function which is decreasing. But if we have a b between 0 and 1, we're going to have a function which is increasing. Now let's look at our p and our q. Now an exponential is different because it only has one asymptote, a horizontal asymptote. And our p in this case is actually just going to be our horizontal shift. And our q is going to be our actual asymptote. So our q value is going to be the horizontal asymptote and it's going to look something like this. And once we have our asymptote, we can actually draw our exponential function. So let's look at our domain and range. Now a domain for an exponential function is going to be any real number. And the reason for that is we're going from negative infinity all the way to positive infinity. So our x is just going to be an element of any real number. Our range, however, is going to depend on whether our a is positive or negative. Now, if we've got a positive a, our range is going to be any y value greater than q, because it never goes past q. However, if we have an a that is less than 0 negative, we're going to have a y which is going to be less than q. And that is because our graph will go from q all the way until negative infinity. So now we're on to inverse graphs. And what is an inverse graph? Well, an inverse graph is any graph reflected across this line, this y equals x line. And it's denoted by a little -1. So if you see f of -1x, or y to the negative 1, you know they're asking for an inverse graph. So let's do an example. Here, I have an exponential of f of x, and it's cutting at 0 and 2 and negative 2 and 0. So now how are we going to determine the inverse of this graph? Well, firstly, let's draw it. So let's just draw it as a reflection across the line of y equals x. So this will be f to the negative 1 of x, and we're just going to swap the x and y values. So this point would just be 2 and 0, and then the y-intercept will be 0 and negative 2. And that's the inverse graph. So now how are we going to determine the equation of an inverse function? Well, let's do an example with the linear function to show you how. And all we're going to do is just swap our x and y's again. So I've got y is equal to 3x plus 7. So y to the negative 1 is going to be x is equal to 3y plus 7. And then we're just going to solve for y. So 3y is equal to x minus 7, and y is going to be equal to x minus 7 over 3. And that is the equation for an inverse function. So now we're looking at the inverse graphs of parabolas. So how we're going to inverse a parabola is we're just going to reflect it across the line y equals x again. And it's going to look exactly like this. So this is going to be our f to the negative 1 of x. But we have a problem. When we do our vertical line test, we see that this parabola cuts the ruler at two different places. So it will cut here and it'll cut here, right? And this means that this inverse is not a function. So how we're going to make it a function is we're going to have two different types of restrictions. Now our first restriction is going to be x has to be greater or equal to 0. And this means that we have to get rid of all negative lines. So we're going to erase this line here, and we're going to erase this line here. And this is what we're going to be left with. So it's really important that we understand both the range and domain of both f of x and f to the negative 1x. So let's look at the range and domain of f of x. For the range, we can see that it goes all the way from positive infinity to 0. So y is just going to be an element of positive infinity to 0. And we're going to use a square bracket because we're including it. Now our domain is going to be pretty similar. For our domain, we're only going to include this part of the function because we've erased this line. So we're only going to look from 0 to positive infinity. So that's going to be our domain. X is an element of 0 to positive infinity. Now for our inverse function, let's look at our range and domain. Now for our range, we can see that our graph is going to go all the way from positive infinity to 0 over here. So y is an element of infinity to 0. And for our domain, it's going to go from 0 to positive infinity. So domain x is going to be an element of 0 to positive infinity. Now we're going to look at our second restriction. And our second restriction is that x has to be less than or equal to 0. So now what we're going to do is we're going to erase all positive lines, which is going to be this line here and this line up here. Now, just as before, we had to work out the range and domain, we're going to have to do that again. So let's look at the range and domain of f of x. Now let's look at f of x's range. F of x is going to go all the way from positive infinity to 0. So for range, y is going to be an element of positive infinity to 0. But domain is going to be different. Now we can see that in domain, we're going from negative infinity all the way up to 0. So domain, x is going to be an element from negative infinity to 0. Now let's look at the range and domain of our inverse. So our f to the negative 1 of x. For our range, we are going from 0 till negative infinity. So y is going to be an element of 0 to negative infinity. Now let's look at our domain. For our domain, we're going from 0 all the way till positive infinity. So x is going to be an element of 0 till positive infinity. So now we're going to do inverse graphs with exponentials. But before we can understand that, we first have to understand what a log is. Now a log is another way of writing an exponential equation, but by making the exponent the subject. So I'm going to do an example with you. Here we have y is equal to b to the x. Now x is our exponent, and we want to make that our subject. So we're going to write x is equal to log b y. And that shows us how we've taken our x as our exponent and made it our subject. So let's do a graph now. Here I have an exponential graph with the formula of y is equal to 3 to the power of x. So remember, when we're determining the equation of an inverse function, we are going to swap our x and our y's. So if I draw the inverse of this function, its formula is going to be x is equal to 3 to the y. But remember, y always has to be the subject of any function's equation. And we're going to use logs. So y is equal to log 3x. And that is how you work out the equation of an inverse exponential function. So now let's move on to a question. And in this question, we're going to integrate all of the knowledge that we've learned so far. So let's look at the scenario we've been given. We've got a parabola of g and an exponential function of f. Let's read our additional information. So we know that f of x has an equation of 2 to the power of x minus 8. And g of x is equal to ax squared plus bx plus c. The graphs intersect at a, which is the turning point of the graph g, and the x-intercept of the graphs f and g. And our first question is, determine the coordinates of a and b. So let's look at a and b. The first thing that we should notice is that a and b are the intercepts of the exponential function, and a is the x-intercept. So let's solve for that one first. So a is the x-intercept. Now when solving for an x-intercept, remember we're always going to make our y equals 0. So now for our f of x, we're going to make it 0, and it's going to be equal to 2 to the power of x minus 8. We're going to bring that 8 over, and we have 8 is equal to 2 to the x. Now we know that 8 is actually 2 to the power of 3, so we're going to rewrite it as 2 to the power of 3 is equal to 2 to the x. And now because we have the same bases, we can drop them, and we have x is equal to 3. So the coordinates of a are actually going to be 3 and 0. Now let's do b. And b is the y-intercept. So now when we're working out a y-intercept, we're going to make x 0. So b is going to make x 0. So now we're going to take our equation, and we're going to have y is equal to 2 to the 0 minus 8. Now anything to the power of 0 is 1. So y is going to be equal to 1 minus 8, which is negative 7. So y is equal to negative 7. So our intercept for b is going to be 0 and negative 7. So now our next question is to determine the asymptote of f. Now remember, the formula or equation for an exponential function is y is equal to a times by b, x minus p plus q. And it's this q that we're looking for, because that q is our asymptote. So now if we're looking at the formula of f of x is equal to 2x minus 8, you can see that this minus 8 is our q. So the asymptote for f is just going to be q is equal to negative 8. So now our third question is to determine the equation of h if h of x is equal to f of 2x plus 8. So the first thing we're going to write down is the f of x. And f of x is equal to 2 to the power of x minus 8. Now what this means is that any time there is an x in this equation, we're going to replace it with 2x. And then we're also going to add 8 to the end of the equation. So h of x is going to be equal to 2 to the power of 2x now minus 8 plus 8. So the end equation is just going to be h to the x is equal to 2 to the 2x, as these two will cancel. The fourth question is to determine h to the negative 1 in the form of y equals. Now remember, anything to the negative 1 means we're trying to find its inverse. So let's first write h to the x, which is equal to 2 to the 2x. Now remember, when we're finding an inverse, we're swapping our x and our y values. So the inverse is going to be x is equal to 2 to the 2y. Now when we're working with an exponential function, we have to use logs. So we're going to use logs to make 2y the subject of our equation. So 2y is going to be equal to log 2x. But now we still have this 2 and we just want y by itself. So we're going to divide everything by 2. So y is going to be equal to a half log 2x. Our fifth question is to determine p if p is a reflection of h to the negative 1 about the x-axis. Now remember, if you're reflecting anything about the x-axis, all you're going to do is make your x value negative. So let's write down the formula of h to the negative 1. Y is equal to a half log 2x. So now all we want to do is make this x negative. So y is equal to a half log 2 negative x. And this negative actually comes to the front of the log equation. So your final equation is going to be y is equal to negative a half log 2x. Our sixth question is to determine the equation of g of x in the form of y equals ax squared plus bx plus c. So let's look at our parabola. Our parabola, we've been given our turning point and one other point. So we have to use the formula y is equal to a x minus p squared plus q. Now, we know that the p and the q are our turning points. So if we have our turning point, which we do, we can just sub them right in. So y is going to be equal to a x minus 3 squared plus 0. So now all we need to solve for is our a. So let's use that extra point to determine what a is. 4.5 is equal to a 0 minus 3 squared plus 0. So 4.5 is going to be equal to a negative 3 squared. So 4.5 is going to be equal to 9a. And therefore a is going to be equal to a half. So now our equation looks like y is equal to a half x minus 3 squared. But remember, the question wants it in the form of y is equal to ax squared plus bx plus c. So all we're going to do now is just FOIL it out. So y is equal to a half x minus 3, which is going to give us y is equal to a half x squared minus 6x plus 9. And now all we need to do is sub in that half. So we're going to get y is equal to a half x squared minus 3x plus 4.5. And that is our final equation. Our final question is to sketch g of negative 1 onto the graph and give a restriction. So g of -1 is going to be our inverse, which is going to look like that. Now remember, we can have one of two restrictions. We can either make x greater or equal to 0, or x less than or equal to 0. For x is greater than or equal to 0, we're going to get rid of all of our negative lines. And our graph is going to look like this. For x is less than or equal to 0, we're going to get rid of all of our negative lines. And our graph is going to look like that. Okay guys, that's everything. I hope you've learned a lot from your Excel lesson on functions. I'm your host Josh. Until next time.